So in topic 4.2, so we're going to talk about trigonometric function of angles. But I remember that I actually have learned this in high school, and I'm pretty sure that you have seen this in high school as well. Okay, but the syllabus doesn't differ that much. So basically what I'm going to tell you is just revision and something that you have already seen. Okay, so here let POQ be a right angle triangle with acute theta. So remember the terms acute angle theta. So acute angle means it's going to be an angle between 0 and 90 degree. So as shown in figure A below. So place theta in standard position as shown in figure B below. So basically I have a right angle triangle. So what is a right angle triangle? It is when you have one of them is remember in the triangle you have three angles. So here 1, 2 and 3. So when you have one of them is right angle, so which is 90 degree, that's what you have over here. So this is called as being a right angle triangle or a right triangle. All right, so if I were to refer, let's say this is going to be my theta. So the line that goes right next to it is going to be called as the adjacent line. So the line that is going to be the opposite direction, opposite to the theta. So it's going to be called as the opposite. And of course, the longest line on the triangle, so which is referring to the OP over here. So that is called as being the hypotenuse. So if so it says over here, then P is a point on the terminal side of theta. So what is a terminal side? So terminal come from the word terminate. So terminate means stop. So here, so we start this angle start on the right axis, and then it stops somewhere over here. So this is called as the terminal line. Okay, and the terminal line, so for example, let's say here we have a point P which is on the terminal line, and this point P has a coordinate of x and y, and of course the length from O to Q is going to be x distance, and the length from P to Q is going to be y distance, and we can get the hypotenuse. The hypotenuse is represented by r, and we can get the value of the hypotenuse by the Pythagorean theorem. So this is the Pythagorean theorem. So it's nothing new, you have seen that before. Okay, or in Malay it's known as theorem Pythagoras. So for example, let's see if I have some like this. So this is going to be my right angle triangle. So theta is going to be somewhere over here. So let's see if I have a value of 3 and 4. So how do I find what is going to be the value of r? So r is just going to be this value square and square rooted. So I'm going to have r is going to equal, so why is my equal up there, by the way? So I'm going to have r is going to equal 3 square plus 4 square, square root. And if you press your calculator, you will get that 3 square plus 4 square. That is going to equal square root of 25. So which is going to equal 5. So therefore here, so we know that the value here is going to equal 5. So that is the Pythagorean theorem. Okay, and this is called as the 6 trigo functions. So they are in the formula over here. It says like find, it says evaluate 6 trigonometric functions. So these are going to be the 6 trigonometric functions. They are the sine, the cos, and also the tangent. So if you're not familiar with this, what is cosecant? So cosecant is basically 1 over sine theta. So that is the cosecant. Secant is actually 1 over cos theta, and tangent, cotangent is actually 1 over tangent theta. Okay, so how do I memorize it? It's going to be the opposite. So sine s is going to become c when you 1 over that thing, and c is going to become s. So sine become cosecant, not secant, and cos become secant, and tangent cotangent. So that is very obvious. Okay, and we know that how the formula goes. I'm pretty sure you have known this already. So the fact that, so let me put a page over here. So when you have a sine of theta, so it's going to be it's going to be opposite over the hypotenuse. So when you have cos, it's going to be adjacent over hypotenuse. And when you have tangent of theta, So that is going to be, what do you call that, TOA, opposite over the adjacent. So that is the formula. So the way I remember this is so this is ka, and this is TOA. So it's going to be so ka TOA. Yeah, I'm pretty sure there's another way of remembering this, or like you might actually remember this in Malay. It doesn't matter, as long as you know that it's going to be sine is going to be opposite over hypotenuse, cos is adjacent over hypotenuse, and tangent is going to be opposite over adjacent. And cosecant, for example, so we know that it's going to be 1 over sine theta, so therefore it's simply going to be 1 over opposite over hypotenuse, and we know that this is supposed to be flipped around, so it's going to be hypotenuse over opposite. So it's going to be the same for the case of 1 over cos, so which is secant of theta. It's also going to be flipped around, so it's going to be hypotenuse over the adjacent, and for the case of cotangent, it's going to be adjacent over the opposite. Okay, so adjacent means sebelah, the line right next to it, and opposite, of course, it means the opposite, bertentangan. So if I have, as I drawn to you before, if this is going to be my angle, and my right angle, theta is going to be over here, so this is definitely going to be the H, so which is the hypotenuse, and this is right next to theta, so it's going to be called as A. So A stands for the adjacent, and O is going to be the opposite right here, so it's called as, obviously, it's going to be the O, so which is opposite. Okay, so what else should I remind you about? I should remind you about the reference angle. But before we go to reference angle, so basically this is how our axis look like. So we can divide that by 4. So we know that I've sketched this before previously, and the subtopic before this, that this is going to be 0 degree, this is going to be 90 degree, here is going to be 180 degree, and this is going to be 270 degree, or in terms of radian, so this is going to equal pi radian, this is going to be pi over 2, so this is going to be pi radian, and this is going to be 3 pi over 2 radian, and of course if this is 360 degree, and that is equivalent to 2 pi radian. Okay, if you notice, this is sort of like we have 4 compartments over here. So compartments, I'm referring to this, and this. Okay, so whatever that falls here, so this over here is called as the first quadrant. So if I say first quadrant, so I'm referring to this. This is why it's called. And here, so this is called as the second quadrant. Okay, and here this is called as the third quadrant, and this one obviously, so it's going to be the fourth quadrant. Okay, so when I say first quadrant, I'm referring to this, second quadrant, I'm referring to the space, third quadrant here, and this is going to be the fourth quadrant. So now I'm going to talk about reference angle, and I'm going to be referencing to this quadrant right here. So the definition of reference angle is that, so let theta be an angle in standard position. So the reference angle, theta bar or theta hat, so it's going to be like, we just want to differentiate that from theta. Associated with theta is the acute angle. So basically, what is the reference angle? So it is an acute angle. So acute angle meaning that, so it's going to be an angle between which is less than 90 degree, and it is formed by the terminal side of theta and the x-axis. I want you to bear that in mind. So the fact that it is formed by the terminal side of theta and also the x-axis. So terminal side means that where it stop, so where it stop, and the x-axis obviously. Okay, for example, so let me show you each quadrant individually. Okay, for example, so let's say if I have an angle, so which is positioned in the first quadrant. So let's say it's going to be over here. So this is going to be 30 degree. So this is where it starts and this is where it's going to stop basically. So where is my terminal? So it's going to be here. So this is where it stopped. Okay, and where is my x-axis? So this is my x-axis. Okay, so what happened is that when it is in the first quadrant, so in the first quadrant, so your theta is going to equal the reference angle. So if its theta is equal to 30 degree, your reference angle is also going to be this 30 degree, because this is the angle formed between the terminal, a point, and also the x-axis. Okay, so this is going to be the case for when you have your angle in first quadrant. And first quadrant, it occurs when you have an angle between 0 and also 90 degree. Right, so that is going to be for the case of first quadrant. Okay, and then suppose, let's say I have an angle which is positioned in the second quadrant. Okay, so let's say this is going to be my angle. So we know that this is going to be 90 degree. So I need to have an angle which is greater than 90 degree. Okay, let's say that this is going to be 120 degree. Okay, where does this stop? So it stopped here. Okay, so this is where it stopped. And where's the x-axis? So the x-axis is here. So where is going to be my reference angle? Remember, the reference angle is the angle between the terminal and the x-axis. So this is going to be my reference angle. Basically, when your function is in the, sorry, it's going to be second quadrant. Okay, so the value of your theta hat, the reference angle, is going to equal 100 of 80 minus theta. So that is going to be a value of theta hat, because here for this case, for example, so my theta hat is going to equal 180 degree minus 100 of 20 degree, so it's going to equal 60 degrees. So I know that this is actually going to equal 60 degree. So that is going to be the case when your angle is in second quadrant. So it will be a value which is between 90 degree and also 180 degree. Okay, now let's have a look for the case that it is actually in the third quadrant. Now we're talking about third quadrant. So let's say my angle is going to end up somewhere over here, and this is where it starts and this is where it stops. So it's going to be an angle that is, my angle is going to be greater than 180, but it's going to be less than 270. For example, let's say this is going to be 210 degree. Okay, so it's going to be in the third quadrant. Okay, it's the third quadrant. Okay, so what happened is that where does it stop? So it stopped here. So this is going to be the terminal point. And where's the x-axis? So this is going to be where the x-axis is. So where is my reference angle? So my reference angle is going to be here. So this is going to be my theta bar. So how do I find theta bar? So theta bar is actually going to equal 180 degree plus theta. So that is going to be a value of reference angle. So when it is in the what do you call that? No, it wasn't this. Sorry, this is wrong. So it is actually not supposed to be this. Let me correct this. So in the third quadrant, so your theta bar is actually going to equal so my angle is going to equal theta minus 180 degree. Okay, for example, for this case, what is my theta? My theta is given by 210. So my theta bar is going to equal 210 minus 180 degrees. So that is going to equal 30 degrees. So this is going to equal 30 degrees. And this is where the position is. So that will be for the case when your angle is in the third quadrant, an angle that is between 180 and 270. Okay, now I'm going to move on to the last quadrant. So the last quadrant is going to be a value between it's going to be a value between 270 and also 360 degree. For example, let's say it's going to be somewhere over here. So what is going to be my angle? So let's say for this case, my angle is going to equal 300. Okay, so that is going to be the angle. So what happened is that for the case of reference angle, so when it is in the fourth quadrant, so how do we find what is going to be the reference angle, which is going to be theta bar? So why is it going to be there? Because this is where it terminates, okay? And this is going to be our x-axis. So that is why the theta bar is going to be here. So my reference angle, how do you find the value of reference angle? So that is going to equal 360 degree. So minus our value of theta. And for this case, for example, so I actually forgot my theta. This theta bar is going to equal 360 degree minus theta. So for this case, it's going to be 360 minus 300. So basically, my reference angle is going to be 60 degree. This is going to equal 60 degree. Okay, so that is how you find the reference angle. So depending on which quadrant your what do you call that, your angle terminates. So where does it terminates? Okay, so have a look at this and try to understand them. And I want you to know this very well, that for the first quadrant, that theta is going to equal theta bar. For the second quadrant, theta bar is going to equal 180 minus theta. So third quadrant is going to equal theta minus 100 degree, 80 degree. And for the last quadrant, so it's going to equal 360 degree minus theta. So that is going to be your reference angle. Yeah, so this is the same as what was stated over there. Okay, this is an example. So it's just referring to the figure. So I'm going to specify cos theta, sin theta, and also tangent theta. So this is my theta. So basically it terminates here, for which that is going to be in the second quadrant. So when it's in the second quadrant, so where is our reference angle? So this is where it stops, and this is my x-axis. So the reference angle is going to be here. So this is my reference angle. So it's going to be at this coordinate, so which is -2/3 and square root 5/3. So I know right away that the distance over here is going to equal -2/3. Sorry, there's no negative. This is magnitude. Okay, so this is going to equal 2/3. And then, so if I were to draw this right here, and on this side is going to equal square root 5/3. Okay, if I were to draw it outside, so let me draw it somewhere else. So it's going to be here. So this is my theta hat. Okay, and this is 2/3, and this is going to be square root 5/3. Okay, so but before that, let me remind you one thing. Of course, the coordinate over here is going to be negative though. Okay, so we're going to find what is going to be cos theta, sin theta, and tangent theta. So using the SOHCAHTOA formula. So cos is going to be adjacent over hypotenuse. So adjacent, it's given by -2/3. So that's your -2/3 adjacent to the theta, so which is right next to it. And hypotenuse, so you have to calculate for this case. So remember, r is going to equal, for this case, 2/3 square plus square root 5/3 square root. And judging from the answer over here, I suppose that you will get r is going to equal 1 over square root 5. Okay, so that's how you know this is going to equal 1 over square root of 5. So you use the same idea. So for sine as well, sine is going to be opposite over hypotenuse. So the opposite is going to be this value. So square root 5/3. So it's going to be square root 5/3 over 1 over square root 5, which simplifies to square root 5/3. And tangent is going to be opposite over adjacent, which is these two values. And it's going to equal -5/2. Okay, one of the way that we can actually check whether our answer is correct or not is whether you get a positive or negative. Okay, so here what happened is that our theta, so that is going to be in the second quadrant. Okay, the thing that I haven't told you about this quadrant is that, so in the first quadrant, only cos is going to be positive. Okay, so let me put that with a, yeah, so let me use a different color for that color that I don't usually use so that we can see that clearly. Should I use a green? Let's use a green. Okay, for the case of first quadrant, only cos is going to be positive in here. And for the case of second quadrant, it's going to be all. No, this is actually not right. Cos is positive, is going to be here. So this is where fourth quadrant, so only cos is going to be positive. In first quadrant, every trigonometric function is going to be positive, whether it's sine, cos, tangent, all of them are positive if it's in the first quadrant. If it's in second quadrant, so it's going to be sine is going to be positive, other than that negative. Third quadrant, it's going to be for tangent. Okay, so how do I remember that? So this is what my teacher teach me before. This is what I learned in school. So it's called as being cast, C-A-S-T. So C-A-S-T. But remember, it starts with quadrant 4, quadrant 1, 2, and 3. So when we have a look at the values that we had before, so where's the values? So here. So you see that this is going to be in the second quadrant. Okay, so our angle is in second quadrant. So this is what happened over here. Okay, so it falls in the second quadrant, and we know that based on the CAST formula, C-A-S-T, for this case only sine should be positive, and that is what happened over here. So only sine is positive, so cos is negative, tangent is also negative, so we know that the calculation is correct. Okay, and then let me clean this. You couldn't really see what's going on if I don't clean this. So we're going to do the same for beta. So previously we have a look at the angle theta, and now we're going to have a look at beta. Okay, the thing about beta is that, so this is where it terminates, and this is going to be the x-axis. So if you notice, what happened is that theta and beta, so they are actually equivalent. Why are they equivalent? Because they have exactly the same reference angle. Okay, and because they have exactly the same reference angle, so it's going to be the same as this as well. So that is why when you find the value, so they are going to be exactly the same. So basically, so you can actually have two angles that refers to the same reference angle, and this is going to be one of the example. And of course, if two angle refers to the same reference angle, automatically the trigo values, the cos, sine, tangent, and so on, they are going to be exactly the same. Okay, so I have prepared some exercise for you to try right here. So give them a go, and make sure that you get all the values for the solution.